Hello. In this program, I'm going to show you how to do the Zilab 4.14 convert to binary. As long as x is greater than 0, output x mod 2. So remainder of division by 2. So when you take a positive integer and to convert it into binary, you're going to repeatedly divide by 2. And every time you divide by 2, you get a remainder of 0 or 1. And those are the bits that you output essentially. So output x mod 2, so you take the number, divide by 2, the remainder gets output as 0 or 1, and then to do the next division, you reduce the number by dividing it by 2. So x equals x divided by 2. And this is also a good example to check if a number is even. So the reason I want to write this program, even though you're supposed to do this in Zilab, it's good practice for you to rewrite it in Zilab, is also to show you how to check if a number is even or odd. So let's start by doing our includes. So we're going to start out by taking a whole number from the user and we're going to convert it into binary. That's our goal. So it's going to main, no functions at this point. We haven't done that yet. So int, let's say decimal num equals 0. That's what we're going to read from the user. So cout, you tell them enter a whole number, and I will convert it to binary. Okay, that's our goal. Okay, and then you read into decnum. We read that number. Once we have read the number, now here is our, let me add some comments here. So user input, that's where we read the number. Here we are actually loop and do the conversion. So we're going to loop and convert from decimal to binary. So while decnum greater than 0, that's what our algorithm says. As long as it's greater than 0, so if you go here and look at the algorithm, it says as long as x is greater than 0. So if you take a number, for example, 11 or 12, you first get the remainder, right? 12 mod 2, the remainder is going to be 0. So we output is 0. Then you take that 12 and you divide by 2. 12 divided by 2 is 6. Then you take that 6 and you find the remainder again, 6 divided by 2. And if you keep doing that, the series of zeros and ones that you get is actually your binary number. So you're going to take this number and you're going to say cout decnum mod 2 because I just want to output it. And I don't want any space or anything after that. Then I'm going to reduce decnum by half. That means decnum, this you all know, is the same as decnum equals decnum divided by 2. That's what that is. It's a compound operator, right? Same as this. So we reduce the number by half. Then it goes back and checks, is that number still greater than 0? If it is, it does a mod 2 and it outputs it. So that's all we are doing here. Let's see if we can get that to work and see what we get for that. So you run it, and when it compiles, it says enter a whole number, and I will convert it to binary. So I know the number for 3 is 0011. So we get 1, 1 with no preceding zeros. That's okay. So let's make a few changes here. I like a new line after that. So the cursor goes to the next line. I like some spaces here after that to put in my number. And let's run it again. And so let's put in 15. 4 ones is 15, right? Run it again. Maybe try a different number. Say 256, right? And that's 256. So let's try a different number. Wonder if it is not giving me. Let's try 64. Okay, so it doesn't give me the trailing zeros. That is actually, there should be some trailing zeros after that. So those are some things that you can work on. But let's try. Maybe try 15. Okay, so 15 seems to be working okay. How about let's try 23. Yeah, so anything that has ones and zeros, but if you type in numbers that are actual with powers of 2, then you need to have the trailing zeros, which it doesn't seem to put in. So, but anyway, this program can also be used to check if something similar to this can be used to check if a number is even or not. So if you want to, for example, check if that decnum is even or not, so you could say if decnum mod 2, you know a number is even when you divide by 2 and the remainder is 0. So if decnum mod 2 equals 0, then you say cout even number, even number. If it is not 0, then you know that it is an odd number. So no else if, just else. Cout odd number. And you should have something to catch the 0 at that point in time. So actually the 0 will get caught into the even number. So if you run this and put in some numbers, let's try 22. It says that's an even number, and you get your answer for that. Okay, so that's a good way to check if a number is even or odd, and this is a good way to convert a decimal number to binary. Now you can do, like I said, you can do a little bit more to get the leading zeros and the trailing zeros and all that, restricted to 8 bits, 4 bits, and you can do multiple different things. But that kind of shows you how to convert a number to binary, or how to check if a number is even or odd.